Hey guys, welcome back. In today's video, we are going to cover circular link or circular doubly linked list. In the previous video, we covered doubly linked list, and in this video, we'll start with how we went through, or we can say we'll backtrack a little bit, and I'll show you what we have completed till now. First of all, we completed our simply linked list, which was just nodes passing or connected to one another, and the last node was pointing towards them. Then we covered circular linked list in which the last node was pointing towards first one, and it was an example for if we consider Spotify playlist, then after we can say listening to all the songs, the first song is getting played again. After that, we started with, you can say, doubly linked list where we had a playlist, and each playlist, you can say, was switching to songs, and in each playlist, the songs were in a linked list format. And once the is suppose a song A is been played completely, then we move to song B. And once the song B is completed, we have the option to move to song C directly. Along with that, we have a option to backtrack. That is, we can directly play song one or song A again. Now, what happens when you can say circular doubly linked list is basically our first pointer is connected to the last pointer, or head is connected to tail, and the tail is also connected to head. So, what happens is if you want to, after you can say completion of the playlist, we will directly move on to song one. And again, if we want to move from song one, we want to listen to the last song again, then we can directly move on to the tail as well. So in this video as well, or you can say in this linked list, we will basically have this as the node, or you can say our node will have three components, that is value, pointer to the previous node, and the pointer to the next node. Now let's understand how each and every function is going to work, or you can say functions which are going to be changing the size of the linked list. So let's start with this one, append. If we want to, you can say, add a node to the end of the linked list, then what we'll do is first our new node will start pointing towards the last node, and then what we'll do is our new node will again also point towards the first node, that is the node A. Let's increase the size of this. And yes, and after this, our first node, that is A, will also point towards our new node, that is the first head node, and then we'll remove, like after pointing, this will be removed. This plus, and our tail pointer will also be moved from the last node or the towards our new node, which is our new tail. And this is how we'll be adding our new linked list. And this node, last node, will also point to a new node. Yes. And now let's move on to the next function. If we want to add a node towards the start of our linked list, what we'll do is our node will start pointing towards our first node. Our first node, which was pointing towards the last node initially, will now point towards the first new node. Then the last node, which was pointing towards the first node, will remove the pointer and will start pointing towards the new node, which is now our head. And this node, the new node, will start pointing, just a sec, will start pointing towards our last node. Along with that, our pointer will be moved from here towards the new node, and we would be successfully added, or you can say prepended our node to the linked list. And let's move on. Suppose we want to add a new node towards middle of the linked list or anywhere else, a part of the first and the last position. Then what we'll do is our new node, suppose we want to add between C and D. And what we'll do is first our new node will point towards C and point towards D. That is the previous and the next. C and D will be severing its, you can say, lengths. C will start pointing towards new node, and we will also start pointing towards new node, and we will be successfully added, and the node will be successfully added. So basically this is the same concept we used last time for you can say doubly linked list. And if we want to remove a node, that is if we want to remove a node from the end, then what happens is the head pointer will be removed, which was pointing towards the tail node, and it will start pointing towards the new last node, that is this one. And then the last node, which was pointing towards the first node, will be removed, and our tail pointer will also be moved from the last node towards our new last node, which is over here. And this node will be deleted, and our new last node will also be started pointing towards our first node. and our last node will be deleted. Suppose we want to delete our first node and we want to move our head pointer to the second one. Then initially first we'll move our head pointer over here. Our last, you can say the last node which was pointing towards the first node will now point towards this node will now point towards our new node, and our new node which was initially pointing towards the first one will be will be changed and will be pointing towards the last node again. And this is how we'll be, you can say, removing a node from the start of our linked list. And suppose we want to remove a node from in between, let's say if we want to remove D, then what we'll do is simply we'll delete the pointer from here, which was pointing C to D. We'll start pointing it towards the next node, that is over here, let me name it as E. And then E will start pointing from here as well. E will now point, which was initially pointing towards D, will now point towards C. So what we'll do is basically we'll iterate till D and then we'll sever the connections from C to D and directly move the connection from C to E. Similarly, we'll sever the connection from E to D and directly connect to C. And this node which is left will be automatically deleted by our garbage collection. Let's start with our, you can say, node function, which is our classic. So node will take value of that will define the function. And it will take a value, which is the value of our node. So self dot value will be equal to value. Then self dot previous will be equal to none, and self dot next will also be equal to none. And we have completed implementation of our node. Now we'll start with our linked list function, that is circular doubly linked list. And we'll create our initialization function over here as well, and it will be self dot head, which will be none, self dot tail, which is our last pointer, will be none as well. Lastly, self dot length will be 0. Now we'll start with our first function, that is appending. Before moving to our str function, we'll be writing this function, so self, and it will take a value. Now what we'll do is we'll initialize our node. Node will be equal to, we'll get the class and set the value, and we have created our node successfully. We'll be now proceeding with the appending part. If we'll check if the head is none, that is if our linked list is empty, then what we'll do is self dot head will be equal to new node, so it will start pointing towards our new node. Self dot tail will also be pointing towards the new node, and since we have, you can say, circular, so each next and the previous pointer will be pointing towards itself. So self dot head dot previous will be pointing towards our new node, and self dot tail dot next will be pointing towards the new node. And over here, I can point it out that we have written as self dot head dot previous. Instead of that, we could have directly written new node dot previous equals new node, and new node dot next is also equal to new node. But for the understanding purpose, I have changed that. You can also use the same thing which I just mentioned. Now what we'll do is, suppose if linked list already exists, then we'll start with the new node. So Next, which was earlier pointing towards our head, the tail pointer, will start pointing towards our new node, and new node dot previous will be pointing towards our tail pointer, which is the end initially, and then new node dot next will point towards our head, then self dot tail will now point towards our new node. Lastly, self dot head, which was initially pointing towards the old self dot tail, will now point towards our new node, which is our new tail. And we have successfully implemented the appending method plus equals 1. And this concludes our appending method. Now let's move forward with our prepending method, and then we'll move with the str method. This will take self, this will take value, and we'll check or we'll directly create our new node first. We'll take value as the response. Now we'll check if self.head is none. We didn't that up. Okay. Then we'll just copy the scenario because it is the same. Else, what we'll do is our new node dot next will point towards our self.head. Then our self.head dot previous, which was initially pointing towards our tail, will now point to our new node, and then new node dot previous will point to our self dot tail, and in the end, what we'll do is self dot tail dot next will be pointing towards our new node as well. So what we initially did over here is first, our next or the new node will start pointing towards the old head pointer. Our old head pointer previous, like it was, you can say pointing towards our tail, will now point to our new node, and then our previous pointer, new node, will start pointing towards tail, and the tail pointer will next point towards our node. You can say new node. And at the end, what we'll do is self.health will be equal to new node, and then we'll increase the length. And this concludes our function for prefend. Now we'll start with the str function, and I hope I don't have to repeat this. If you have doubts, you can refer to my previous lecture. str function is just where we will be iterating over our linked list and printing the linked list out. If we don't do that, what happens is basically we'll get a random address printed over here, or we'll get self.head printed over there. So self.head will start from the head, and while temp node, let's name it as values instead of value, and let's move on str dot value do temp node will be equal to temp node dot next, and what we'll check is if temp node is dot next or temp node is equal to set dot head, then we'll break. And why is this condition important is because we are starting from the head node. After tail, when we go next, it will start pointing towards the head again and will iterate over the same thing and it won't break. So in order to stop that, we have added this condition. Also, why it will, you can say initially we have head, but we have updated it over here. So it will directly point towards the second node and after that we'll compare. So the head pointer would be, you can say, coming twice or in the initial loop. Once the linked list has successfully completed or traversed till the end, the head pointer will be again called and the loop will break. Now let's return the dot join if values else will write empty. Now let's try everything out. I'll create the class. So it will be CTLL, will be circular doubly linked list. And now let's append. Now what we'll do is we'll have integrated or you can say we have appended and prepended. So we'll print our linked list in the end and let's see if it is working. Okay, there we got attribute LSS no attribute head. Okay, I guess we have mispronounced that or we have a spelling error over here and yeah, we have it over here and we have it over here as well. And we have to solve the error. So let's check. And as you can see, we have successfully implemented it over here. So what we have done is we have two ones. Let's remove this or let's name it as -1. And as you can see, we have, you can say, implemented this over here. And we have our linked list completely printed out. And all the appended method is working correctly along with prepend method. Now what we'll do is we'll move on to our next function and that will be traversing our linked list reverse in a reverse order. So the function will be the same. What we'll initially do is we will keep our function same as the temp node. So our temp node, what will do is it will point towards self dot tail. While temp node values not append will make it into string. Temp node dot value will be appended, and temp node what we'll do is we'll come back, so it will be instead of next it will be previous. Now we'll check temp node is equal to set.tail, and once set.tail is hit, what we'll do is we'll break our loop, and in the end we'll return the same thing. Join values, the values of this, else will print empty. Now let's test it out if it is working or not. So we'll print DLL dot reverse traversal, and let's see if it is working. Okay, one method. We have done the same thing over here. We have this, we have this. It is breaking values, these from values. So let's see if it is. Okay, yeah, I got the error. We haven't, you can say, called the function correctly over here. That's why we are getting the address. So here you can see we have printed our linked list in the reverse order successfully. So this function is working correctly. Now what we'll do is we'll move to our next function that will be searching a value in our linked list. So let's start with it. We'll start with stem.head, or you can say self.head. You can also start from tail as well. There is no difference. Instead of next in the for loop or in the while loop, we'll directly write previous. So what we'll do is step node and temp node dot value is equal to value which we are looking for. Then we'll directly return index. Else what we'll do is temp node is equals to temp node dot next, and index will be increased by 1. As temp node is equal to self dot head, that means we have returned to overhead again. Then we'll break this loop, and in the end we'll return -1. Now let's search for a value and see if it is working. Let's search for 3 and see what's print. And it is at an index of 4. So let's check it. 0, 1, 2, 3, and 4. Yeah, it is successfully printed. Now what we'll do is we'll check something like 100, and let's see what happens. We get -1. That means it was not found. So I'll turn it to 3. We'll save it. comment this part down as well. Now, what we'll do is after completing our search function, we'll move to our, so you can say our next search function, which will be searching at an index or we'll be fetching a value at a particular index. So, what we'll do is that let's name it that value at index. It will take self and index as an input. What we'll do is we'll check uh, self.head as none. Then we'll return a little false. We can increase this gap over here. Uh, Index is less than 0 or index is greater than self.length minus 1. And why we have added minus 1 is because index starts from 0 while the length is starting from 1, which we have initially set 0 over here. Will be starting from 1 while the index is starting from 0. That's why we had to add in self.length minus 1. Then we'll return index out of range error. Now what we'll do is if index is less than self.length divided by 2, then we'll start iterating or we'll take our temp node, start from the head, and we'll start with the looping in range of index below temp node is equals to temp node dot next. Then what we'll do is if that is not the case, if index is greater than self dot length when it's half, so what we'll do is temp node will be equal to self dot tail for range self dot length minus 1, and I know hope you know why it is minus 1 over here, and then we'll start from reverse, that's why we'll keep this minus 1. Temp node will be equal to temp node dot previous, and at the end we'll return temp node dot value. Now we have implemented this function. Let's see how it is working, or if it is successfully working, that is. And let's search at an index of 5. And we have successfully got 4. It's confirmed 0, 1, 2, 3, and it is 4. 0, 1, 2, 3, and it is 4, and it is 5. Correct. Now we'll move on to our next function, that is set value, or we'll update a value at a particular index, then comma value comma index. And what we'll do is we can say implement the same stuff for finding the or reaching towards our node. So it will be none. then we'll return empty if index as less than 0 or index is greater than self.length minus 1, then we'll return index out of range. What we'll next do is we'll check if index is less than self.length out of B, and we'll keep temp node starting from the head pointer. For I in range of until index, we'll increase the temp node or we'll iterate towards the temp node. And in the else part, we'll do the same thing, but we'll do it for tail over here. So in range of self.length minus 1 and tail index minus 1, temp node will be equal to temp node dot previous. And at the end, what we'll do is temp node value will be equal to our value. And we have successfully updated or we have updated our function and the value. Let's try it out if it is working or not. So there is no need to print that value. Let's what do first let's update this since it is negative. We'll update the value of 10 at an index of 1. Let's see if it is working. And as you can see, we have updated over here and we have got 10. And let's test it out for one more, or you can say at the end, so we'll know if our end part is also working correctly. We'll update at an index of, let's say, 6. Okay, what happened is temp node. Okay, yeah, we haven't. I guess we have made a mistake over here. It will be self.tail, not temp node.tail. So, yeah, there we go. Let's see. 0, 1, 2, 3, 4, 5, and 6. At an index of 6, we have successfully updated 100. So we can say we have completed this set value function as well. Now we'll move on into our interesting function, that is insert at a particular index. So what we'll do is insert, let's say, anywhere in HTML. It will take cell, it will take index, it will take a value. Now we'll check if the linked list is empty. So what we'll do is self.head as none, then we'll return empty. If that is not the case, and index as less than 0 or index is greater than self dot length. Now, why we haven't written -1 over here is because if we want to input or add an element at the end, then it should be greater than the actual length of the linked list. That's why we are considering this as self length. Otherwise, for the searching part and for the popping part or removing or node, we won't be considering this. We will be adding -1 at the end. So you can say this is the reason why we haven't kept -1 over here. And let's raise an error. So return index out of array. Now we'll check if index starts from 0 or if index is 0, then we'll do is we'll directly call our prepend function and pass on the value to it, while if index is equal to self.length, then we directly call self.append function and pass on the value to it. Else we'll create our new node, initialize it, we'll pass on the value. We have successfully created our node. Now we'll check if index is less than self.length. Not 2, then we'll write temp node will be starting from head. Now why have we written -1 over here is because if we want to update an index at 2 or we want to add it over here between 1 and 2, then we'll first reach 1, then create a new index or create a new node which will be pointing towards 1 and 2, and then we'll sever the relationship between 1 and 2. So before moving ahead, let's implement this. Next, for the else case scenario, it will do temp node will be equal to shell.tail or less than range shell.length till index comma -1. And this will be temp node where temp node dot next. Sorry, not temp node dot next. It will be temp node dot previous. After iterating, what we'll do is new node dot next will be temp node dot next. Then new node dot previous will be temp node. Then temp node dot next dot previous will be our new node, and temp node dot next will be our new node, and self dot length will plus equal to 1. So what we did over here is new node dot next, that is once we have reached till 1, what we did new node dot next is equals to temp node dot next. We pointed it towards 2. Then new node dot previous is equals to temp node. So the new node which is going to come between 1 and 2 will now point towards 1 as its previous pointer. Then temp node dot next dot previous, that is we initially temp node is 1, so next will be 2, and the previous pointer of 2 will now point to our new node which was initially pointing towards 1. Then temp node dot next, so the next pointer of 1 will point towards our new node, and we would have successfully updated our linked list and added our element or added our node. So let's test it out if it is working or not. What we'll do is hidden dot insert, and we'll insert at an index of 3, and the value will be 40. Just like this, and let's check what is working. At an index of 0, 1, 2, and 3, the value is updated. Now let's see if it is working for our, you can say, backside part. So we'll update it at 7 as well. And let's check 0, 1, 2, 3, 4, 5, 6, and 7. 7 has the value 40, and as you can see, we have successfully updated it. Previously, it wasn't there, it was around something else, and now it is 40. So let's move on to our deletion function. Now, what we'll do is we'll start with pop first, or which will be a function which will remove the first element of our linked list. So we'll take self as an input, if self dot head is none, that means our linked list is empty. So we'll return empty. The self dot head is equal to self dot tail. That means we only have one element in our linked list. So what we'll do is self dot head is equals to none, and self dot tail is equals to none. Self dot length will be equal to 0. So what we have basically did is we have checked if the linked list is empty, then we have returned empty. And if the head is, you can say, head is pointing towards this tail, that means we only have one node. So we will be removing that node and will point everything to none. Also, what we can do over here is we can also sever the circular relationship which we have. So what we can do is set dot head dot next will be pointing towards none, and set dot head dot previous will also be pointing towards none. Since it is circular, so I felt like this is important. And what we'll do next is we'll consider a scenario hold head, which is self dot head. Now self dot head will be, you can say, the next node. So hold head dot next, that is the second node. So if the old head is 0, then our second node or next one will be 10 over here. Then self dot head dot previous will point towards the self dot tail pointer, and self dot head, no, not self dot head, it will be self dot tail, which we have to update. So self dot tail dot next will be pointing towards our self dot head. And then since we have removed the old node, we'll remove the connection for old node as well. So dot previous is equals to none, and old head dot next will also be equal to none. And in the end, what we'll do is we'll decrease the length by one. And we have successfully, you can say, removed the node from the start. Now we'll write our pop function. What will initially do over here is it will take nothing as an input. We'll do the same logic, but it will be for, you can say, tail part. So self dot head is none, then we'll return empty, then f, and let's copy this from here as well. We'll go over here, increase, else what we'll do is whole tail is equals to self dot tail, then self dot tail is equal to whole tail dot previous, then self dot tail dot next will point towards our self dot head, then self dot head dot previous will point towards our updated tail value. It will be self dot tail, then we'll delete our old node. So whole tail dot next is equal to none, and whole tail dot previous will also be none, and at the end it will be self dot length minus equals 1. Let's compare this. So what we initially did is we created our old node and we created our old tail node. We moved our head pointer towards the next, and here we moved our tail pointer towards the previous node. Then what we did was self dot previous is equals to tail. So directly we created a new connection, and over here we did the same. So tail dot next is now pointing towards our head. Then over here what we did was self dot tail dot next is pointing towards our head node, and over here head, or you can say the previous counter of the head, is pointing towards our new updated tail node. And then we severed the connection of the old nodes, and over here we did the same, and we have, you can say, updated our value, and we have successfully implemented our function for, you can say, popping the first value and popping the last value. Now what we'll do is we'll create a new function, remove any node. What it will take is self and index, then we'll check self dot head is none, then we'll return empty. If index is less than 0 or index is greater than self dot length minus 1. And remember, I said like for the pop and the search one, we'll keep this value as minus 1 only. Only for the insertion, we will be keeping it as self dot length. And as you can see, we have updated it over here as well. So return will say out of range, or let's be specific, index out of range. I've completed this. What we'll do is index is equal to 0, then we'll directly call self dot hop first. If index is equal to self dot length minus 1, then we'll call self dot pop function directly. Then what we'll check is the else part. Here too, we'll check if index is less than self dot length. At 2, then we'll start iterating from temp node at a head, or we'll start iterating from head for range. Then go to index, We'll update the node counter. So temp node is equals to temp node dot next, else our temp node will start from tail. So it will be set dot tail, um, for underscore n range of set dot length -1 index over -1. Temp node is equals to temp node dot previous, and then we'll start updating our node. So temp node dot previous dot next, and we'll point towards our temp node dot next. So how we are basically removing here is, before like writing the code, I'll make you understand. Suppose we want to remove this 3 from a linked list, then we'll iterate from start till we come over 3. Then what we'll initially do is we'll check if our, or we can say we'll directly connect. So what we'll do is, instead of 2 connecting to 3, we'll directly make a connection from 2 to 4, then 4 to 2, and we'll get a linked list removed, or we can say node removed. This will be quick. So what happens is temp node dot next dot previous. So now 4 will be pointing towards 2, will be temp node dot previous, and then temp node dot previous is equals to none, and temp node dot next will be none as well. So what we have done is we have removed the connection of the node we are removing, will be minus equal to 1, and at the end will return true, which we have updated. Now, before testing, let's write our last function, which will be delete entire linked list. It will do nothing, it is the simplest function. So what it will do is basically cell dot head, you can say dot next is, or dot previous. We can directly like this. You can say is equals to none, cell dot tail is equals to none, and cell dot length is equals to 0, and it will be removed. Over here, I know we have, you can say pop, you have written these conditions as well. It is, they are not necessary, they are just for the show. Like garbage character will anyways remove the entire connection and sever all the connections and empty our string memory. So this is our, you can say, delete entire linked list to node. So what we'll do is we'll directly check our pop and pop host method from this only, cdll or cdll. This will be, we will be popping at index of 0. Let's print on this. You know, we'll pointing it from, what was this? We'll be moving from index 3, and then let's see if it is working. So over here, this the next is null type. Okay, it is at 182. So let's check over here. What's the mistake? And we have head. We have started from head. This will be temp node.text. Over here, no any node. Then type object has no attribute. Next, if added head, this is our index. over here, tempo node dot let's see. We have the objectives next. So null type no attribute next. Should work. So, so I figured out the error. Basically, what happened is over here we were not returning anything. So without returning, it was directly you can say after running this part, it was directly going towards it. It wasn't finding any code, so it was getting an error. So it is necessary if we are using it, if all, if and else or else if as well, we need to return something. Maybe it could be none or it could be anything. Over here, I haven't returned anything. So as you can see, we are successfully able to run all this stuff. And let's check. We have removed at zero. Zero has been removed. At third, we have removed second one. So let's see, zero, one, two, and three. It was three, and three is successfully been removed. Now let's count zero, one, five, six, seven, and eight. Let's remove at eight, and let's see if it is getting removed at an index of eight. Print cd ll, and let's see. And as you can see, it got removed, and it was our last method. And finally, what we'll do is we'll call delete all, and we'll check if it is removed. And we have successfully removed. This covers our entire doubly linked list.